Yesterday, if you remember, we were talking
Yeah.
about the basic fundamental idea about DevOps, that how DevOps is implemented, why DevOps is implemented, why DevOps is necessary, and how DevOps is different from Agile. What is the key differences between that, and how, first of all, Agile came up in as a software delivery lifecycle or a software development lifecycle by
Vishal,
completely
your voice is
ruining.
not audible, Vishal.
Your voice is not audible, sir.
My voice is not audible. Now is it fine?
Yeah, something disturb. Yeah, now it's fine.
Okay. I think I went a little bit back from my mic. Sorry about it. Okay, so yes, so I was talking about that we already have a little idea about this thing, like what is a software development life cycle. Waterfall was there. Agile came into the picture. What were the problems of waterfall? Why Agile came into the picture? Now, what all the things Agile faced a little short of? So, how did DevOps come into picture and kind of added a patch to Agile and made it work like the way it was actually intended to be, right? We talked about the complete virtualization. Basically, I mean, you have your, let's say, the continuous integration, continuous deployment, continuous testing, continuous building, all those things in a pipeline format going on, starting from the developer writes the code. After that, we are starting the automation. It is skip. I think I have put the file in the drive, right? I think I've put it in the drive now. So it keeps on going, and ultimately till the deployment, configuration management. And I talked about the 11 tools that are there, which we shall be starting to learn today, right? So the first tool that comes into picture is basically GitHub, right? So GitHub is the cloud version of Git. I mean, you can think that Git is a local version, GitHub is the cloud version. Just like, let's say, Microsoft Office local version, Office 365 is the cloud version, right? So Excel local version, Google Sheets cloud version, like that. Okay. So we have a local version and a cloud version. The cloud is GitHub and the local is Git. Okay. Now I would typically start with GitHub and not Git. Why shall I do so? Is because GitHub has got a GUI, so at least you can see things happening over there. Git will be completely Linux commands. Okay. So first we will do GitHub. We will do a little bit of Git today, and we will put it at rest. Monday we will finish up the Git part. Okay. We shall not try to do like everything at a single point of time, right? GitHub we shall first try to understand. So there are many aspects of. First of all, we need to understand the technology of Git, how Git works, because GitHub does the same thing on cloud, Git does the same thing on local. But ultimately, the thing we need to understand what it is doing and how it is doing. Right? Fine. You can see that. Okay. All right. So let us go ahead and let us try to actually start understanding the process of a repository, Git repository. Why it is called a repository? What is happening over there? Let's try to have a look at one by one to these things. Right. Okay. I will open up Chrome. I need to open up Paint basically. You got the new drive link. You got it right. I think either you have received the email, otherwise go and check in your shared with me. You'll find it out. Okay. I created a folder with the name DevOps something something with the entire information DevOps 8 a.m. Okay, like that. Yesterday's drive is already there. I changed the name. Huh. In which one? Hang on a second. Hang on a second. Two folders are there, right? Fine. Na? One folder is for DevOps I exclusively created, and another one was the older one that was the AWS one. I renamed that. The older one was named as AWS DevOps. I renamed it to only AWS. I created a separate one called DevOps. Cool, na? And I did this because I added Sonil and Mithun, these people also, right, over there. So everybody in the same folder, right? Just no, check in your shared with me. You'll find it out. I'll just show you still, just in case you're a little confused. I'll just show you this. Okay, so the two folders you right now are having. In fact, for DevOps, only one folder, that is this one. DevOps 8 January 2020, Vishal ongoing, right? This is the way we are writing right now. What time, which date it started, who is taking the session, and whether it is ongoing or finished, right? So this is yours, right? So in this one, I have already put the notes on DevOps and the DevOps introduction. Right? And whatever your AWS is going on, that is fine. That will anyway finish up in another 1 or 2 sessions. So that folder will be sealed after that, right? Okay. Let me open up Chrome. Sorry, I mean JS Paint. Try this. Wi-Fi wants this one. I think it's a little slow. It's taking a lot amount of time, which is pretty much unnatural. Now it comes up. Can you see? You can see. Okay. So for me only, it is taking too much amount of time. Oh, I shouldn't have restarted. I I gave a reload and it is taking once again a lot amount of time. Now it is fine. All right. So it will open up. Or is JSPen itself is slow? Probably. I don't know. Yeah, Google is loading pretty fast. This app itself is going slow. Okay. So let's try to understand first of all from the perspective that what exactly is a repository, right? And what all different models of repository we have, and what kind of a model Git is or Git or GitHub is following, right? And how is that helping us compared to the other models? This is the first point of discussion, right? I'll create a notepad once again. I'll create a notepad once again. So I shall not write everything over there, but some points probably. Okay. So first thing is that uh, who is that? Why am I getting an echo once again? Repository. Next thing we should talk about is I'm just writing down the points, okay, for our discussion. What is a repository? At the end of the session, you should be able to answer all these questions. Okay. What is a repository? What are the different architectures of repositories? And then comes point number 3, where we shall talk about that which architecture Git follows, and how is that a better fit compared to the competitors, I mean, or let's say the other options, whatever. Point number 4 is basically um, actually doing Git, right? Right. So we shall do that. So first, let us discuss on point number 1, 2, and 3. The first question is that what is a repository? A repository is a place where you can store certain things. Okay, and here we are talking about, of course, source codes. The developer writing some code, so they are storing their code in certain place, certain yeah, whatever certain place. That particular place is known as a repository. Okay. Now, does okay? That's a wrong spelling. Repository. What is the spelling? Is it correct? No. Repository. So another thing is I get confused with spelling sometimes. Another thing is that does a place that can just store source code become a repository immediately, or does it require some more attributes? Only storing a source code is okay enough, or do you need some more attributes? Okay. So when you talk about a source code repository, I'll just take a gap over here. When you talk about a source code repository, what I want to mean is that source code based repository basically, right? But I'm writing source code repository. Okay. So means a repository which is typically designed for keeping source codes. I mean, Google Drive can also you can consider as a repository. Yesterday I was talking about this, right? Google Drive. We are sharing videos, we are sharing media through Google Drive. So that's more or less a repository. But the thing is that, but no, actually the point I'm going to talk about, Google Drive also has that feature. More or less, Either we know or we do not know, but it is there. We'll come to that. But the ultimate thing is that GitHub was designed to be a source code based repository only. On GitHub, you cannot put media files and images and all those things, right? Probably you can put a PNG image, but it is not exactly a image sharing platform. It is a text based platform. Okay, it is always based on texts. It always takes care of like which lines of text were earlier there, which line of text has been added right now, which has been deleted. It keeps track of all the changes. It is text based because source code is always text based, right? So it is source code based repository. Now along with that, there is another property which comes into picture, that is version controlling. What does the word version controlling mean? You already know this thing. You have learned in S3. What is version controlling? What is the purpose of version control?
Keeping a history of the item.
Keeping the history of the item. So in S3, when you did version control, what you did, you uploaded a file. You saw that file is there. You enabled version control. You changed the content of the file and you locally re-uploaded that. So now you are seeing on the front screen the latest file only, but if you go inside in the drop down, you'll find out all the versions present over there. 10 times you do 10 different versions will be there, right? And all the previous things will be retained in the respective versions, right? A repository is a repository only when to become a repository, honestly, the English dictionary definition does not mention that it has to be a version control system. But nowadays, the system has been like this that if you call yourself a repository, you should have some sort of a version controlling going on over there. So if I write a code today and tomorrow if I change the code and upload the code and I process the code and take it till the end, but in production something bad happens, I should be immediately be able to roll back to the previous version of the code because it is still not lost. Even though I uploaded file one's modified version, the older version of file one is still present over there. And as soon as I feel okay, this new version is not working, I need to rework. But of course, I cannot say that to the production guy, right? That okay, production, let it be down, let me rework, then it will be up. No. So revert back to the previous one, right? How do I do that? Because this is providing me that option, right? So just redo the pipeline once again, not using the latest code, but using the previous code. That's it, right? So that is a version controlling that comes into picture. So source code based repository which enables version control, that is basically the two attributes of GitHub or Git. Okay, clear? Any doubts so far? Anybody on these two things? Yes, no? Okay, I'm audible, right? No, like
Yes, Vishal.
I know this one.
It's clear.
Yeah, yeah.
Right. Okay. So now the second question which you need to answer is that what are the different architectures of repositories? Now this is something that I want you to actually understand. Now that we got the point, so when you're talking about architecture of repositories, you're talking about architecture of something that can store source code and that can do version control. These two things it should be able to do, right? Now the question is that what are the different architectures we have of repositories? Let us see it. Who are the users of a repository? Who uses a repository? You developers use a repository to upload their codes, and probably your manager might want to have access to the repository sometimes to go ahead and check out whether they are actually doing something or not. How will managers check? They'll see, oh, yesterday there are 5 codes, today there are 6 codes. Okay, so developer is working like that. Okay, so anyway, so your stakeholders, right? So the people who need access to a repository are your developers. I will just increase the font. Developers, stakeholders. When I say stakeholders, I mean other stakeholders apart from developer. And you need, basically, since we are talking about DevOps over here, you need Jenkins to have an access to the GitHub. Otherwise, Jenkins is the guy I told you yesterday who pulls the code from GitHub and then processes it forward, right? So Jenkins should have. What I mean to say, the CI tool, whatever CI tool you are using. Here I'm writing Jenkins because that is the most popular one. If any other CI tool you're using, or if you plan to do it manually, not exactly DevOps, you are doing manual things. Still that, so after development, it is testing. So the tester should have an access to the repository so that they can pull the code from there, right? Something like that. So basically, repository if you keep, a guy uploads, a person sees, a person takes it forward. All these three people need to have the access to this particular thing, right? Now, the main architectural point of view, architectural part comes into picture when we see from the point of view of how easy it is for the developer to work on this particular thing and keep on syncing with the repository. Okay, two things. So see, the other stakeholders are not really worrying about actually putting something in the repository. Nobody does it. Neither Jenkins does it, nor the other stakeholders do it. Only the developers are the people who have to develop, and they have to put the code over there. If the developer does not put the code over there, then the pipeline processing does not even start, isn't it? It starts with the developer pushing the code. If developer has not pushed any code in the repository, the pipeline process does not even start. Getting the point? So now how easy it is for the developers to work on that particular repository and syncing their whatever they're doing with the repository as and when they wish. They might not wish to sync every single change. Like, I'm writing a new line and that got updated. Writing another line, I'm deleting, got deleted. They might not want it because other developers are also looking at the same repository, right? So if I am a developer, you are a developer, and I already have a working code uploaded over there. So you want to work on a particular feature on that, let's say on a software. So you will take the first existing code and then you will start working on it, right? Now, every line I am adding and removing, if that keeps on getting syncing over there, then there's a problem because the code that is over there is unstable, that is constantly changing. You want it to be over there only when you are very sure that it is working, right? But now how easy it is for you as a developer to control that thing, that when you want it to be over there, when you do not want it to be over there. Or let's say I told you that you want the code first, otherwise how will you work? Let's say the project is going on for so long. Now you are a new person have joined, you need the existing thing, then you will build upon that, right? You cannot suddenly start from zero. So how will you get the existing thing? How is it for you? These things come into picture. So there are two different architectures, remember this, for repositories. Okay. Okay. This thing I'll write in Notepad. The photo I'll draw here. Centralized and decentralized. Okay. Centralized and decentralized. Now, what happens in a centralized architecture? In a centralized architecture, we have the photograph like this. Understand the architecture. It will be very easy once you see the photo. Okay. Think about this. Let's say this is the Git cloud, GitHub. Okay. This is GitHub. So, or basically the cloud storage, the central storage, basically, right? So why do we use GitHub? Because let's say, okay, you will understand this point. So this is the central repository. I'm not saying centralized repository. Central repository. Architecture is centralized or decentralized, whatever. Central repository, right? Just like you have that. What do you call that? Either you have separate air conditioned machines or you have centralized air conditions, right? So that kind of central repository, everybody can access this, whoever is required, right? Like just like that. So in a centralized architecture, always remember these are two different terms: centralized architecture and central repository, completely different. In decentralized architecture also there is a central repository. It has to be there. There has to be a place where everybody is uploading, right? Central repository. So, and let's say there are certain developers, local systems, like local computers. So let's say these three. Okay, it looks a little bad, but anyway, let's tolerate this. So these four, let's say, are the local computers of the developers. So this is, I'll just write down, let's say, um, local repo one. Okay, local repo, or forget about local repo. Just say that local machine. Okay, it is a local machine, and all of these are local machines. Okay, I'm not writing everywhere. All of these are local machines. Now, in centralized architecture, what happens if a developer is sitting on this local machine? He wants to work on this particular code that he was working on yesterday or something, whatever his code is. He has to, step number one, get connected to the central repository, the first thing, right? He needs an internet connection or whatever VPN, whatever you've set up, whether it is your internal or some other third party tool, whatever it is, depending upon how whichever way you're getting connected, he needs to get connected to the central repository first. So once he logs in, just like let's say, I mean, it does not really mean that he has to open up on Google Chrome browser or something. I mean, you have client applications, right? Like let's say on my computer, I have got WhatsApp installed. There is a WhatsApp application which is installed over here. I don't go to Chrome and open up WhatsApp. I mean, when you do web WhatsApp, I do not go to Chrome and open a scan the code and open. I don't do that. I have a WhatsApp application installed over here. I'll click on it. It is already configured with my phone number. It will open up my chats immediately, right? So you have client window through which you can log into this. It doesn't through internet does not always mean that it has to be through browser. Okay. So this local machine, all these developers, they're getting connected to the central repository and they're working over there. Okay. And whatever change they finally feel that, okay, fine, this code I have worked on. So now I can say this change I have made to the code. I think this should be actually be, committed. Committing means telling the world, okay, see, I have done this thing. This is it. Right. What I have done, probably in the testing, it might fail, but at least as of now, this is the solution I'm providing. That is committing. You're committing a change, right? So one is you're just changing. You're changing, adding one line, deleting two lines, doing something. But ultimately, when you're satisfied, you commit that. Means in the central repository, now the previous version of code was that a new version will get created. A version gets created when you commit. You changing lines and adding a full stop, removing a full stop. That should not create new versions. Doesn't make sense. Once you're pretty much sure enough, whatever you've done, that is okay. You commit, it creates a new version. So the developer gets connected to the central repository and he is, committing the code once he is okay. And at the end of the day, he disconnects himself from the central repository. He goes home. Next day he comes back. He again connects himself and he works, right. So that looks a very secure thing because nobody can steal the code and run away. There is no theft and all those things. So that security part is fine. But the main difficulty over here is that you cannot work outside your office network probably, or if it is a cloud based also, and you can actually, it is a public cloud, you can actually work from outside your office also, there is an access. Still the problem comes into picture, you cannot work without internet. 24/7, if you are, or I mean 24/7 or whatever time you are working, you need to have an internet connection. If the internet connection is destroyed by some means, let's say I was connected, my internet goes off, so the session that is opened with me is now a dead session, right? Doesn't make any sense. And whatever I'm doing right now, I will play. If I press and commit, it will keep on rotating and say there is no internet, and all my changes are gone, right? So I have to like control everything and copy that, keep it something, and wait for the internet to come back. Once the internet comes back, again go on login over there. I'll definitely not found whatever I did. I have to again paste it back. I copied it, right? I have to wait for. I mean that is how people normally do it. Sometimes I mean the people who hate centralized architecture, they tell like this. I have heard this from I went for a seminar. They're like, "Mm, there is no internet, you lose your entire code, you again have to write it." So one guy told, but sir, you can just copy and keep it with yourself till the internet comes back, right? So that's for practical. Copy and keep it. Once the internet comes back, paste it. Why are you writing once again? So anyway, but the problem is that it is very much dependent on internet. If there is no internet, there is no workability. Now this might not look like a limitation because internet usually typically we have. Okay, that might not look like a limitation, but this was considered a limitation in an earlier age. In today's age, in the age of geo, we don't have a problem, but in the earlier age, that was a problem. So there is no internet because internet costed too high, right? Without internet, you cannot do it. Think about it. Just think about 3 years ago, 1 GB of data costed 200 rupees, right? So and we are, Git came into the picture like 5 years, 6 years, 10 years. So that point of time, internet was very costly. So this centralized architecture, people were a little bit skeptical about using a repository altogether because they are thinking, oh, we have to use a repository, it is centralized repository. I need 24/7 internet connection. That is too high, much cost, high priced, and all those things. Also, nobody can do work from home probably, right? Because if you want this much of security, you will probably not allow the usage outside your office network, right? Nobody can do work from home, so you are kind of becoming not so much productive with this architecture. That was the main thing. So then came the decentralized architecture. Okay. I'll give you examples of repositories who follow this on a one example. I'll give decentralized. You know that is Git. Centralized and example would be SVN. Okay, Apache Subversion, sure, which is in short written as SVN. Okay. Now, what happens in a decentralized architecture? See, I'll copy the same photograph once again. Oh, okay. Copying pasting doesn't work. How it works? So here, what we are having, see, this local machines that we are having, additionally to this particular architecture, we have something known as a local repository also. So local repository one for this guy will have a local repo two, let's say, okay, and so on and so forth. Local repo 3, local repo 4, right? So you got local repo is a short for repository. Local repository 1, 2, 3, and 4. Now, what is the benefit we are getting by, additionally giving this concept of or bringing into this concept of local repository? What we can do right now, we can clone the entire code that is present in our central repository in our local repository, which is stored in our local machine, and we can completely, do all the functionalities. Like we can change the source code, we can commit the changes, we can commit 1,000 times in my local repo, and once I am back to the internet, I can just push it back to the central repository. Okay, Vignesh, you missed this part. Listen to me. In a decentralized architecture, we have a local repository concept. So all these local machines we have a local repo 1, 2, 3, 4, like that. Okay, we have local repositories. So developer one, first he logs into his machine, he creates a local repository. This one central repository is GitHub, the local is Git. Okay, he creates a Git in his machine. He gets connected to GitHub. He needs internet definitely, because central server you need to connect, you need internet. He pulls the entire code from GitHub to his local Git. He disconnects from internet. He keeps on writing code. He commits changes. Everything is happening in his. So his local computer starts behaving like a that folder, that particular folder, whatever he has said that this particular folder is going to be my local repository, where he has enabled the Git activity. So that particular folder itself behaves like an actual complete repository. It can do version control. It can track all the changes, right? So both the attributes is over there. It saves the source code. It tracks the change. Tracking the change means doing a version control, right? Controlling the versions. Once he is back to the internet, he can push everything back to the central repository. So if he has done, let's say, 10 commits, 10 different commits, he is working on multiple features. Here he has done 2 commits, here 3 commits, altogether 10 commits he has, right? Nothing is so far reflected in GitHub. But once he is back to the internet, he just fires one single command, all these things are pushed to GitHub, right? So you can work independent of remaining connected to your central server. You do not need that. You touch the central server. Oh, I am getting an alarm. See, typically you get up at 9 o'clock. So so now you are connected to the central server only when you require to get connected to that. You don't need to keep a open session with that, because now think from this. They told that was a security, that you are not allowing them to copy the code. What if my developer runs away with the code and sells it to some my competitor? Think about it. You are working in, let's say, Dell, and your big competitor is, let's say, for example, Microsoft, and you take it, or let's say Microsoft, Google, you sell the code to them, right? Now you definitely lose your job in Microsoft, because Microsoft will fire you as soon as they find that you have done that. Google will take you in the job. Why not? So I mean, the company is ultimately losing something, right? So this was considered a very good architecture, because nobody can steal anything. But then they thought that, okay, fine, we should at least believe so much to our employees, right? Why will they steal our code and run away? But here, what we are getting much more flexibility in working, because once again, remember, in the age it came out, there was very difficulty on the internet part. It was very costly. right? So it is so much of cost. In India only, it is now so less cost. Outside, it is still costly. Internet. A friend of mine. So when I was in abroad, that point of time, India was also costly. But a friend of mine, he's telling, no, there is no change. We are still paying the same rate. You people are getting in much more, lower cost in India. It is very cheap. Here the connections are not that stable and all those things. We complain so much. But the thing is that if they give us stable connection in that price, we will prefer this over that. This is so cheap, right? You're recharging 400 rupees. You're getting like 3 months 1 GB every day. Who gets that much? So that is the thing. So it is so costly that they decided to go for this one. Now here actually, honestly speaking, the security later they found out is much more tight in decentralized architecture, because this idea became lame over the period of time. This idea became very lame that you have to stay connected to a session and then only you can play with it, right? Because that just doesn't make sense. I mean, it ended up being like that. And at the time when centralized architecture came into the picture, people thought it makes a lot of sense. But later they thought it doesn't make any sense, because you always need to get connected to the particular thing. Always you are connected and you are working over there. If a lot of people are working on the repository and it gets slowed, then you are also getting affected out of that, right? And kind of your local machine has no role to play. It is just a way for you to get connected, and you're ultimately working on it. And working on a remote, just think about it. If I You have probably seen this thing when you take a webex control, or let's say some control to your office machine, how slow and how disgusting it is to work, right? So everybody working on central repository. So they chose to cut down cost over everything else. But when the cost become a little low and people thought that okay, we can bear the cost, they tried to get the performance matter boosted. And then decentralized architecture was much better. And from the actual networking perspective, think about it. Security is more tight in decentralized architecture, from the no, not from the employee stealing and running away. From this perspective, that here you are opening up a session and keeping it open. Anybody cuts in into the session, they can see the entire transaction, what is happening. Here you are not keeping any open session. You connect to it, you get the data, you switch off the session. Fine. Let the cloud be as it is. Let me be as myself. Once I'm done, at the end of the day, I can connect, I can push the code, I go home and sleep. Right. So it is very short session durations, which gives you more security. Clear? Is everybody okay with this discussion? Everyone?
Yes.
Anybody any doubt? I'll write a reply from everybody, please.
Yes.
Okay. All right. So now that we have understood this particular point, so centralized and decentralized, as I told you, GitHub and Git, that is your decentralized architecture. Apache Subversion is an example of centralized architecture. I'm just taking these two names because right now only these two repositories are still alive. In centralized, others are dead. Nobody uses it. SVN, somebody still use because of two reasons. Number one, people love Apache. I mean, honestly speaking, I also love Apache. Every single field you go, there is a solution from Apache, right? So people love Apache. Now that is actually the second reason. The first reason is that legacy projects already started with SVN. They don't have the correct infrastructure to convert it into a decentralized format. So they are continuing that. So there are many projects specifically in the let's say companies who do projects for very long, like TCS, Infosys, where one project keeps on happening for 6 years, 7 years, 10 years, like that, right? So like government projects and these kind of projects, right? Those kind of projects are still maintained on SVN. TCS maintained the government of Karnataka project that we had, that was on SVN. Okay. SVN, I mean, all these tools you can block or restrict the who can access it and all those things. You can do that. So it is pretty much secure. I mean, Apache Subversion we could have only used from Ahmedabad and Bangalore. Bangalore, what team was there, and one. I mean, the main team was in Bangalore. A small team was in Ahmedabad. It is still there. In fact, I guess the project is still going on. So now they had an access. We had an access. Nobody else, right? So you can restrict the access, all those things, right? Now in Git, it is much more new. I mean, you can restrict access using email IDs, just like Google Drive. A folder only these people can have. Who can edit, who can view, all these things you can do, right? So GitHub can be done in that way. It is pretty much easy. SVN had an older way. There was an XML file. You need to go. You need to add some IP addresses over there. So it is IP based. These IPs are allowed. These IPs are not. If somehow the IP changes, then you have to restructure the XML file like that. So Apache Subversion practically is dead. No new project will start with SVN, but still some older projects are running on Apache SVN. Okay, and Git is the one that needless to write, but still let me do so. GitHub, and this is Git over here. So GitHub and Git, both of them allow you to do version control, which is the best part, right? So you can do locally, you can keep on doing your versions, keep on committing, and at the end of the day, you can push it over there, right? Okay. So this is our this particular. So now this question is also answered. Which architecture Git followed? How Git follows? How is it better fit compared to the other options, right? We already understood this point. The security part coming into picture, the work flexibility coming into picture, and probably we should not say it, but still the internet thing also coming into picture, right? So I'll just note it down over here. Flexibility, right? In terms of internet means what? Means cost, right? Ultimately, it is cost based, cost based flexibility as well as work based, because you don't need to stay connected. You can work from your home or whatever, right? Because in your local machine, you can commit from anywhere, right? I mean, in my local machine, I can commit from anywhere. I want to share a photo with you. I have to post it on Google Drive. I want to see my own photo. I can put it in my machine. I can see it, right? What is the problem about that? Isn't it? So in local machines, so cost and work both are flexible, and the transactions. Transaction means what? Opening a session, copying or whatever the data, and closing the session. That is called a transaction, right? Transactional, workflow. In a centralized, it is not transactional, because you cannot call it a transaction if it is open 24/7. It is not a transaction. It is just a open connection. That's it. But it is a transactional workflow. Opens, does, closes. Khatam. Right. Okay. And then we are going to actually do GitHub, right? So we all are good till this point, right? Okay. Just give me a minute.
Yes.
I'll come back from washroom. Just a minute. So let us go ahead and let us actually continue doing. Let's just start doing GitHub. Okay. First of all, what I would ask you to do, I should have told you before I took the break. Okay, just take 5 minutes of time and open up an account in GitHub. It hardly takes 2 minutes. Okay, just go to github.com. So first of all, do this. Go to github.com and then sign up. Okay. I will not sign up. I have an account. Put your username, anything, right? A username is not your email ID, just a username, anything. Anything is fine. You should remember that, because you need to put it in multiple places. Email address, password, and then what is this puzzle? Acha, this is the donkey, right? The rotating donkey. Huh? You have to keep it straight, something like that. Huh? So this donkey, do this thing, and then it will send you an email immediately. Do it in 2 minutes. It will send you an email. Verify the email quickly. Okay. So you can log in with your username also, or your email ID as well. Anything is fine, right? Alright. Okay. So this is the window that I am seeing. Probably your window might be a little different, because I have this repositories list coming up over here. But anyway, whatever it is, you will find this plus button in the right top corner in your screen, right? Wherever it is happening. So go ahead and click on new repository. Okay. Click on new repository. So now here, see, there are certain options that is coming up. One is repository name, right? You can see your username / the repository name option is coming up, right? It will always be like that. What happened? Go ahead and put some repository name over here, right? So whatever you want, right? Something that probably makes a little sense. Maybe I'll just say my repo, because this I do not need. You cannot have the same repository name twice in your account. Okay, it always has to be unique within your account. But let's say I'm creating something called my repo, or forget about it. Even better, repo uh, underscore morning underscore 8. Better for me, at least, because otherwise it will be overlapping. Probably I will create my repo for someone else also. So repo I'm calling it, right? It supports all the characters, nothing to worry. All the characters does not mean like exclamation mark and all those things. Typically underscore and letters and alphabets, right? I never tried with an exclamation. I don't know. Okay. No, it will convert into a dash. It will not take an exclamation because whatever you are putting over here, that has to be the characters which is supported in the URL bar. In the URL bar, because your repository URL will become github.com/ my username, that is Sona Sona Ram / repository name. This is going to be the URL. Since this will be the URL, you cannot put something which is typically not supported in the URL bar. Means you cannot put a slash, because slash does not and slash means something within something, right? It is not exactly a name. You cannot put exclamation, you cannot put dot, those kind of things you cannot put. Okay. Acha. Now, you may wish to write a description about this, like this is a test repository, okay, for morning 8 batch. Then you have an option for say going either public or private. This is the restriction I was talking about, right? If you're an organization, go for private. Why go for public, right? But private has a limitation in free account. In free GitHub account, I think you can create at most 6 private. I didn't try. I have only 2 private, so I still have an option to go for private. But probably 6 is the upper limit, right? We have to confirm this one because I'm not sure if they have changed it or if my information is wrong. Hang on a second. Let me just check it out. So number of what private, or let's say how many private repo we can create in free Git account. Let me just check it out. Oh, 3. Okay, it has become 3. It was 6 earlier. In January 7 2019, means 1 year ago. Last year they have made it 3. Okay. Okay. Acha. Here it is writing 3 and here it is writing unlimited. Okay, for the first time, developers can use GitHub for the private projects with up 3 collaborations. Okay, 3 collaborations per repository. Fine, I got the point. I'll tell you what collaboration means, but now it is unlimited. So you can keep on creating as many private as you want. Earlier it was 6. Okay, in earlier it was 6. So collaboration basically means if you have a GitHub repository, I have a GitHub repository. I am allowing you, I'm giving you a permission to push codes into my repository. That is called collaboration. So in a free GitHub account, at most 3 people you can add in a given repository. 3 people can collaborate. Otherwise, you alone, you are, if it is a public, it is fine. Public means anybody can push over there, anybody can do, right? You can add an approval. Okay, I'll just not allow anybody to push over here. If someone is pushing, let an email come to me and let me go and check. If I approve, then only it will be added. Otherwise, it will not be added, even though someone is pushing. But in a private, so they are always called collaborators. But in a private, the limitation is 3 collaborators. Okay, so 3 collaborators can come. Anybody with a GitHub repository can collaborate with you in your project as long as you are allowing them, right? If it is a private, you need to give them permission. If it is public, it is public. Someone comes and it is like free advice. People do free advice, right? You are sitting in the public and you are thinking what is going on. Even if it is a personal life, people will pass on free advice, just like that. It is a public thing. People are passing free advices, so freely there. So you should actually approve or whatever you want to do. So this is the difference between public and private, right? So anyone can see the repository. You choose who can commit because you can approve. That's what it is writing. And here it is writing, you choose who can see and commit to this repository, right? Whoever commits apart from you is your collaborator. Let it be public anyway. Acha. Here it is talking about creating a README file. So why it is talking about this? Because first time when you create a repository, there are no commits, right? There are no files, no commits. So there is no version controlling going on. Nothing is going on. It is just a dummy repository ready to be used, but not yet being used. So what they're telling that in case you are not sure how to do it, just check mark this one. So we'll create a dummy readme file and we'll do a dummy commit so that at least one commit will be there. You can go and see how a commit looks like and you can create your own, right? But we do not need it. We'll just click on create a repository. Acha. Before that, there is something known as dot git ignore. You see, add dot git ignore, right? It is telling none. And license. Now, license is not that important, but .git ignore is important. License is also important. I'll tell you where, but very limited scope. Git ignore is a very required thing sometimes. So git ignore is when you are pushing from your Git to GitHub, okay? Or let's say from GitHub you are pulling it back to Git. Means there is a transaction happening between Git and GitHub. If this is happening, which all files you want to be ignored and not to be pulled or pushed, whatever. An example can be, let's say I am a developer and I am writing a development plan. Okay, I am creating a notepad file, create development plan. Okay, first I have to work on this, second I have to work on this, third work on this, and whatever I'm doing, I'm writing done, or I'm keeping an Excel sheet. Day one I want to, but that thing I do not want to push on GitHub, right? When I'm doing the commit, since it is in my project folder, by default it will also be sent over there because my folder whatever is there I'm sending to the GitHub, right? So what I shall do, I'll create a git ignore file and I will keep this file within my git ignore. So what will happen, whenever I will do a commit, and that commit will be committing everything apart from this file, right? If you keep it outside of git ignore, means git ignore is just a file you can go and you can write down, okay, uh, you know game development plan.xls. If you mention the name developmental plan.xls, so the development plan.xls file that you have, that will not be committed or pushed, right? If you have that file over here and you manually you commit all of the, either you go for commit all, okay, so there are two options. You have a lot of files, you commit everything so that you can push them. So you're telling, okay, whatever files are there, I am satisfied, I want to take them to the repository. Or you say, no, I want to take this, right? Now here the problem that comes into picture, if you do not commit everything and you keep on manually committing everything else apart from this one, right, to make sure that this is excluded, you manually are doing this thing. Can you understand such a big effort it is? Let's say you have hundreds of files, one single file you do not want to do this, right? So you have to do 99 times manually commit. Better you do commit all, but you make sure that you mention this file in git ignore, so git will automatically ignore this file and commit everything else, right? I'll show you the usability of .git ignore when we actually do on Git, not on GitHub. On Git, we shall see these things. Yeah? Because there we can create a transaction. Now from Git, we can push something to GitHub. So we can create, we can see as soon as I'm mentioning something in Git ignore, that is no longer going back over there. Okay. All you need to do is to click the green button called Acha. License is like EULA. You know, EULA. You heard about this term? End user license agreement,
Yes.
right? End user license agreement, EULA. So you are putting, let's say you are making a open source software. Do you understand the difference between a free software and open source software? What is the difference? No, free is free, right? I mean, I'm not saying demo or trial. Free software and open source software. A free software may not be open source, but an open source is always free. Okay. Open source means where it is giving you the source code also. This is the software I've built, and here is the source code of the software. If you want to modify and do whatever you want to do. That is an open source software. And the free just means the software is free, but I'm not letting you see this. Like let's say Google Play apps, right? More 90% of the apps are free. Nobody downloads paid apps. Apps are free. So you're that is a free app. But can you see the internal coding of the app? No, you cannot see it. Right? But there might be some app who is showing you the coding also. Probably they have uploaded in the GitHub. They will give a link. Okay, if you want to see the code of this app, it is uploaded in GitHub. That will become open source. So how will the app developers share the source code with the public? Through GitHub, right? So in that particular case, you might wish to add a license. Adding a license does not guarantee nobody is going to break whatever you are asking them not to break in the license. It just guarantees that, okay, I at least told you not to do this. Now you do it, it is your call, right? You cannot guarantee anything. I mean, it is not a security feature. It is just that you have to depend on that human, whether that human actually reads the license and performs accordingly. I mean, according to the rule, you should not drive more than 40 km speed in this road, right? There is a meter. What we do, we are riding fast. When we see the meter, we slow down a little bit so that it does not take our photo, right? We'll be slow down a little bit, you cross the meter, you can go high. That's what we do. Right? So adding a license nowhere adds any security or anything, but it is just that from your stand you are very clear, okay, I am telling this is not to be done. Now you do it, it's your call, right? I can put a case against you, you will die out of that. I am telling, right? That is the idea of adding a license. Nobody really cares about adding a license nowadays. it was a very old feature. People used to add a license, but this git ignore is important, right? We'll click on this green button called create repository, and you will be able to see this thing. People, are you following along with me, or are you just listening? I mean, do one thing. Whenever
Following along with you.
Okay, great, then it's perfectly fine. Just follow along. Okay. So when I have done this thing, this is the screen I'm seeing, right? So this is the screen I'm seeing. You can see there has been an HTTP link, and look at your URL bar, github.com, your user ID / your what repository name, right? That is coming up. Mallikarjun, any difficulty?
Yeah, but for Windows machine it is little different.
For
It is
what?
as for Windows machines.
No,
Uh,
how
it
does
is no, it is asking for download GitHub desktop.
no. You ignore that. Don't download the GitHub desktop. We do not need it. Leave it.
Okay.
Don't no not required to do so. Okay. So here you can see the github.com, and then your username comes into picture and your repository name comes into picture, right? It talks about HTTPS connectivity. If you want to connect to this GitHub account from your local Git, okay. Ultimately GitHub exists because Git is also there, right? So you can see the Git comments are given. We will come to that in a moment, but as of now, let's stick to this one, right? So this GitHub is there. This is if you want to set up an HTTPS connection, and this is if you want to set up a SSH connection. Okay, both it supports an HTTP based connection as well, and SSH based connection as well. Okay, you can go for anything. Okay, how we shall work over here, see what we shall do. We'll first, right now we have nothing in the repository. We do not have a Git client also anywhere that we will push something over here, right? It is a blank repository, and we did not even use the functionality of creating a blank readme file, right? What we shall do, we'll click over here, get started by creating a new file or uploading an existing file. Let us try to upload an existing file, right? We can create a file from here also, but anyway, let's try to upload, right? So it is asking you to drag the files and add it to the repository, or choose your files, whatever you want to do, right? Anybody running anything apart from the Windows, guys? Anybody running apart any below version than Windows 10? Nobody, right?
No.
Okay.
I'm using Windows 7.
You are using Windows 7. I'm not sure about Windows 7. In Windows Vista, I have seen Windows Vista. Yeah, the GitHub does not work. I mean, even though you're using Chrome browser, latest version, GitHub does not work.
Here it's working. Same as your screen it's showing.
Okay. Then it's okay. But in Windows Vista, I just remembered this. So one guy had Windows Vista. GitHub just does not. Git will work. Command line will work anyway. That's fine. But the GitHub window will never open. I mean, it will open, but you cannot do anything over there. Okay. All right. Now, this is the thing. So it's asking to drag and drop. I'll just choose my file. Okay. So I'll take some file. Okay. I'll go up. The file I had created yesterday, notes on DevOps. I'll take this file and I've put it over there. Okay. It is uploaded. Now, can you see it is asking us to commit the change? We can add multiple files also. One commit means that's a version creation, right? I told you commit means creating a version. So in one version you can add one file, one version you can add 10 files. Who knows, right? That's on you. But anyway, we are adding one particular file over here, and it is asking us to commit the change, right? So when you commit the change, you are typically supposed to write down some commit message. This commit message is mandatory to write because this gives an idea. This you can see an optional extended description. This is optional, but the message is mandatory. Whenever you are committing, you are telling, okay, this has to be a version. You need to write a message that what changes you did in this version or something, so that you can at least remember. Otherwise, think about it. Something fails in production, I have to roll back. Where do you roll back? Which version do you use, right? You have not written correct messages. You will never know. Maybe you are committing a change, but one particular functionality is not working over here. You say doing because of deadline, but this particular thing is not working, right? And in the next version, you write, okay, now this thing is working. So you will keep a track by yourself. Otherwise, you will never know what is going on. So let's say I'm saying initial commit adding uh, DevOps nodes. Okay, and I'm committing the change. As soon as I will do so, you'll find out notes on DevOps is coming over here with the proper commit message, right? Okay. If I open up this commit, one commit is telling, right? It will show you the number of commits, how many ever is there, right? It is one, it will become 2, 3, 4, 10, 15, 100, whatever. So if I click on this particular thing, one commit, you will see that the commit is being shown over here, right? Initial commit adding DevOps nodes done by this user committed this many times ago, this many seconds ago. But why I brought you in here is that because if I click on this, you will be able to see a hexadecimal number that is coming up in your URL bar. The same thing you will find here also, in fact. Okay. I typically follow it more over here, but anyway, it is present here also. This is known as your commit ID or your commit hash. Okay. You call it your commit ID or commit hash or version. In we are more habituated to see versions like 1.0, 1.21, like 2.0, like that, right? But here the version is hexadecimal number. Okay. Here. It is not coming on your screen.
Sir, can you please show me how you click this option?
How sorry?
Click the how you come to this option?
Okay, I was in my repository, right?
Yeah.
Originally. And after committing, I saw this window.
Okay.
So what I did, I clicked on the commit.
Okay.
Okay. And then I can see all the commit history. From here I click. You may just click over here also. Just click on this one.
Okay.
No. This will not work actually. This will open up the file itself. Okay. You have to come through this one. I thought that might work. You have to come to commit, and then whichever commit you're talking about, click on the commit message. Okay.
Okay. Okay. Okay.
Click on the commit message. You will find out in the URL bar. You will find commit / your hex number. Right. This number is the one when I told you, remember that Jenkins periodically checks. Yesterday I told, right? Jenkins periodically will be checking the repository, and if there is a change, it will identify. How does it identify the change? It compares with the previous commit number. If there is a change in the commit number, you will find, okay, fine. So now the commit ID is different. So there is a change, right? Whenever there is a commit, the latest commit ID will keep on change, right? And the older commit IDs will be restored, right? Okay, now see this thing. Over here, if you see what it says 118, right? 118 changes, 118 additions and 0 deletions. Whenever you put a file or you change something in the file, it is always considered as addition and deletion. Because if you see, that's what it is. Adding a line and deleting a line. What else do you do? When you edit any text file or you write any text file, we are just adding some lines or deleting some lines. Correct? So how does GitHub track? Now for you, probably it is coming like this. By default, it comes like this. I think for you it will come like this. I have kept the split view on, so the split option. So it is coming like this. Okay, left and right. You will understand why I have done this thing when we shall delete something from this file. So let us delete something and then you will understand. So any change basically means that will consist of deletions and additions. Okay. So if you update a line, let's say here it is written SDLC. If I change this line to software development lifecycle, I update this line. Update means what? Update basically means deleting and adding. How do I make it software development lifecycle? By pressing backspace and then writing that. That means it is deletion plus addition. So one update means that is equivalent to one deletion plus one addition. Okay. If you adding a new line is addition, deleting a old line is deletion, updating a line is addition plus deletion plus addition. Correct? Everybody on the same page? Yes?
Yeah.
Yeah.
Let us try to edit this file and recommit. Okay. So every time you do some change, you need to commit to make sure that see, it is telling 5 minutes ago, right? And whatever your another thing, whatever you can see the first 6 or 7 digits of that hexadecimal code. The first 6, 7 digits will come. Whatever the commit hash is, the first 6 digits will come. See, if I go here, Okay, 3A45 BE10, right? Something like that was coming over there. Come back. 3A45 B till 1 it is coming. Okay, it is not till 10. 345 BE1. The first 7 digits are being shown over there, right? That will always be done. Acha. Let us go ahead, open up this file, and let us change something. So I'll change this SDLC. I need to click on the edit button. Okay. I need to click. I want. Oh, I want to change this SDLC to software development life cycle. Okay. Right. Only this much change I'm doing. Fine. And I want to call it updating SDLC to software. I'm just updating SDLC. Okay, to full form. And I'm commit. Right. Now it changes. I do so. And as soon as I do so, now if you come back to your repository, you will see now 2 commits. File is still 1 only because the same file I changed. I did not upload a new file in the second commit, but the number of commits is 2. And for this file, whatever the latest message is there, that is being shown, right? So this file has been last committed on this one, and this was the message. Had I added a new file, then that new file would be having only 1 commit, but this file has 2 commits, right? Even though altogether the number of commits that is displayed over here is the number of commits that has taken place on the entire repository. If you have pressed the commit button 5 times, it will be 5 commits, right? But depending upon when you're, let's say I am again going to change something in this file, and as well as I am going to upload a new file also. 2 things I want to do together. So in the third commit, there will be 1 file addition and 1 text change. Clear? If I open up the 2 commits now, you'll be able to see the history. See, this was the initial commit, 3A45BE1, and the new commit is also come into picture, right? Okay. If I open this up, this is still in the older format, whatever it was, 118 addition, 0 deletion, right? We are not losing any information over there. If I come back and hit at this one, now you can see, right? 1 addition, 1 deletion. I told you, right? If I'm changing 1 line, that is 1 addition, 1 deletion. The addition is shown in green color. Last time the entire file was shown in green color because the entire file was added, right? And the deletion is shown in red color. If you are in the unified view, it will come like this. It comes like this, right? In your view, if you are in unified. But I typically prefer to stay in split view because it can show me the negative and the positive in both the sides, right? So this one helps me out. Otherwise, you can keep as you want, right? So you can see only the changes being displayed over here, right? Clear? So you can keep on doing, right? Let us upload a new file. Let's upload a new file. So I'm going to, you can create a file from here also because it is ultimately a text-based file, right? So see, name of the file it is just. So I'm saying that created from uh, GitHub. Okay. This file has been created from GitHub window itself. Okay. Cool. I'm writing this. I'm saying that created new file. Okay. See this thing. This guy's message does not change, even though there are 3 commits. Okay. There are 3 commits. First commit message was what? Initial commit. Second commit message was updating SDLC to full form. Third commit message was created new file, right? But since the third commit has only affected this one, right? This file's latest, whatever version it is showing right now, that has already been done in second commit. That is not affected in the third commit at all. So it is showing so every file will show against it for that file, whichever commit it was last updated, that commit message. Okay. So this is showing this commit message and this is showing this commit message. Clear? Are you understanding the point? If I go to the commits and I click on the last commit, create a new file, you'll see there is only 1 addition. Makes sense, right? Okay. Everybody? Is everybody clear what is going on?
Yeah, Vishal.
Yes.
Okay. So every file it will be keeping a track of. Okay. Now, so in this way we can like keep on building one after another. This will not go much far because we are only working with GitHub. Typically, we should do in Git and push it over there. But I just thought that let us see the GUI part first, like so that we can understand when we are doing in Git. Okay. So you understood that when we see the comments, we can find out all the comments followed by their own hash. And now here it is showing half, but anyway, there is a full hash, that is following this, right? You'll find the hashes coming over here. Okay, you will, or whatever you want to call it, hash or ID, whatever, right? And this branch concept, I'll tell you, as of now, don't worry about it. There's only one branch. It says that is the master branch. We can create multiple branches. The branch concept will come into picture. As of now, don't worry. So we can keep on creating files. We can keep on pushing, keep on creating files over there or pushing files from a Git. They'll keep on getting stored over here like this. When you create Jenkins, you will give this URL and it will ask you to come here and take this file, right? If it is a public repository, Jenkins can very easily do it. If it is a private repository, you have to put SSH keys here and there, private key, public key, like that. We shall see that when we do Jenkins. As of now, don't worry about it. Okay. And just to show you, but not exactly using, we will use it once again when we go to this one, Jenkins. If you want to add a key, private public key, that can be done from settings. You can come here and you can use deploy keys. So this is a section where you can put a key. If I put a public key over here and my Jenkins has the private key, exactly the private key of this key pair, whatever public private key pair will come. If it is there, then Jenkins can access this. If it is public repository, nothing to worry. If it is a private repository, Jenkins can only access if there are the keys in the places. If the keys are not there, Jenkins will not be authenticated, right? It will not be authenticated, so it cannot come. So this section we shall use when we will do Jenkins, right? The settings part. Okay. Now, now that we have this thing, let us try to quickly go to Git. Okay, let's try to do a little bit of Git, right? Because GitHub will not be complete. You cannot completely understand it unless you do Git and you push Git from there, because it is a centralized server, GitHub. But your local repository has to be there. Decentralized architecture came into the picture for this reason, so that you can play from local to foreign, right? Let us try to do that. So for doing it, I will not install Git on my local machine, on my Linux. I will take a EC2 instance and on that I will install Git. Okay. So let us quickly go ahead. Is everybody fine? So till this point, shall we go forward? Yes. Anybody? Any?
Yes.
Okay. Let us go ahead and let us try to create an EC2 and let us play with it. I'm going to take an RHEL derivative, Amazon Linux. Okay. I'll not take Ubuntu. I'll take an Amazon Linux. It is not that in Ubuntu it will not work, it will, but let's work on RHEL because that is standard. Okay. I'm taking this one. You can take directly RHEL also. I mean, the same thing. This is derived from RHEL itself. Okay. I don't really worry about all the stuff, so I'll just click on review and launch. Wherever it is launching, I'm fine with it as long as I have an IP address. So I'm going to give it the key pair of nvcentro skp. What is the username?
EC2 dash user.
EC2 dash user. EC2 user. Ubuntu is Ubuntu. It is not yet started.
What is EC2?
EC2 for
EC2 user is the username.
Amazon Linux machines. EC2 user is user. For Ubuntu systems, Ubuntu.
Right. So we have logged in the EC2 console, right? This thing looks wonderfully good. The way they have designed this. Okay, I'll go for an update. So in Ubuntu machines, we go for apt update. Here we go for yum update. The package manager has changed, right? There we will write sudo apt update, right? Get the point? Here it is sudo yum update. Okay, the package manager is yum. You can see it is written over here, sudo yum update. Right. We are updating the system. The package manager, see the package manager, it is like you have Android phone, right? We sometimes update all our apps from Google Play Store, right? So updates all apps over Wi-Fi. Sometimes we are frustrated, we say I don't know what to do, let me update the apps. Okay, nothing good to do. So why do we do that? Because there is a repository, Google Play Store. Think about it, this is a repository where whatever installed apps you have, the origin is this one, you got it from there. So you're trying to make sure that your app is the latest version of whatever is available. That is the purpose of updating, right? So here ultimately this is also Linux only. Android is ultimately Linux, iPhone, all these things, MacBook, these things are ultimately Linux only. I mean iOS, Mac, whatever, Macintosh. So everybody follows the same structure. There is a app store, some kind of a Play Store or whatever application store where you can download the apps from. So whatever you have, you connect with it and you update yourself to the latest version, right? So that's what we did. So now installation of Git, it is very easy. Sudo yum install Git. That's it. I'm putting a dash y for the yes no flag, right? Otherwise it will ask me later that whether you want to continue or not. I'm just putting y. Yeah, go ahead and do that. Sudo yum install Git. Done. It will install Git. Khatam. That's it. So we have installed Git, right? Okay. What we shall do, we shall create a folder which I want to be my local repository, right? So right now I am at my home EC2 user, and here there is nothing, right? I'm creating a new folder with the name my local repo, right? The name really doesn't matter as long as it makes sense to you. My local repo, right? So now we have this folder over here. I'll go inside my local repo, right? And you can see I am inside my local repo. What I'm going to do over here, I'm going to initialize an empty. Acha. We have nothing, right? I mean, no hidden folder also, just dot and dot dot. Dot dot means previous, dot means current. They are relative paths, nothing else. We do not have anything over it. It's completely empty. I'm going to create git init. I'm going to run this command again. I just press some enter, sorry, clear first. Git init and run. As soon as you do so, it will say the see, initialize an empty git repository in home EC2 user my local repo dot git, right? Dot git lsla. A new folder has come, right? If I simply do ls, nothing will show because it is a hidden folder, right? Dot git. Let us go inside dot git and check what is there, right? So see, branches, configuration, description, hooks, head, info, objects, references, a lot of things are there. You will understand these things one by one later. As of now, forget about them, but just understand this dot git is a folder which has all the controlling capabilities that is required to become a actual version control system or a repository. This guy can take care of your, I mean, locally now this folder has become a repository. This folder, within this folder, whatever you will create, they will store a version for that. They'll store every single thing. You can roll back, you can see all the commits, everything, whatever you did on GitHub in that repository. Similarly, this local repo will become a just a repository. You can do every single thing, right? Okay. So now that we are on this particular path, What I want to do, I want to first exactly what we did on GitHub. We'll create a file, right? And we'll write down some text over there, right? So create a file. Or else, what I did over here, I uploaded a file, right? I uploaded the DevOps notes file over there, right? So I'll just copy that file over here in this folder. Why shall I write a new file, right? I'm copying the file. Where is it? It is in home. No, it is in my local. Okay, I need to copy SCP. Forget about it. That is too much of work. Let me create a new file by myself. So I'm creating a file with the name. Let's say file1.txt. Okay, file1.txt is an empty file. And write down some text over here. So this is some text and the third line. Right? Cool. I just wrote some text over here. Okay. So now if I do an ls, we'll find out file1.txt is there, right? Inside my local repo. Clear, na? Getting the point. These are the basic things I'm doing. What I need to do, see now, the process goes in this way. Process goes in this way. Create file, create or copy from somewhere, whatever. Create file. Yeah. I don't know her. Okay. Create file, and after that it is after you have created, you have to go for adding the file, right? Add the file. See what I'm writing. I'm writing technical words. Add the file to the staging area. I'll explain you the meaning, and then only you can go for commit the file. This step you might think, okay, this step was not there in GitHub, right? Another extra step is coming in between. There we created the file, we committed the file. On GitHub, when you press commit, it automatically adds first and then commits. That is why this step was not there. Okay, but here since we do not have Git, it is not GitHub. It will require you to first add manually and then only commit. Okay. So what is a staging area? Think about it. Let's say there is a stage, okay, and you are going to perform something on the stage. So there are a lot of people who are on the stage. Let's say you are a singer. So you are holding the microphone. Now there are a lot of musicians sitting on the stage, but on you there will be that focus light, right? The focus light will be on you. Wherever you go, the focus will follow you, isn't it? They put a focus light on the other people will be there, but they will be on semi-dark, not exactly in focus. You will be on focus light, right? When on TV they'll show the program, they'll focus on you. So that means what? There are a lot of things, let's say in this folder, but you are choosing which one you want to stage. When you commit, only the staged file will be committed. The same thing I was telling you, that if you don't want to put it on git ignore, but one file you want to not commit, you have thousands of files, or let's say 10 files are there, you individually add all the 9 files to the staging area. So think about this. There are 10 people on the stage, 9 people are coming into the focus. So now when a photo is clicked, only these 9 people's face will come. The other person's face will not come because he is standing in dark. Getting the point? So that is what adding to the staging area means. You are telling Git, okay, these files I have which I want to, like commit in this particular commit. And that's a bad use of word, but you're getting the point, right? In this particular version I'm creating, I want to commit these files. I do not want to commit everything I have. I just want to commit, let's say 5 files. I have just 2 files I want to commit in this particular one, right? So the version 1 that will get created, or whatever the version ID, in this version only 2 files will come. The next version, it is there, but I don't want them to right now participate in the versions. Let them be there. I'm working on them. These 2 files you add a version. Okay, that is what we call adding file to the staging area. You can add it, you can remove it from there and all those things, but once you commit, it is done, right? Once you staging area, you can think of an intermediate stage. It is physically the file is not moved anywhere else. It is just adds a flag. Okay, these files has to be committed. Once you commit that, then it is permanent. You cannot do anything, right? But you can add something to the staging. You say, okay, no, I'm not sure. I think this one I shall remove. You can remove it. But once you commit it, it is done, sealed. You cannot change it. Okay. So the first thing you need to do, if I try to do a commit, which is as simple as saying git commit, right? Okay. we cannot do it right now. We have to do a git add. But anyway, so if you want to see what is the current situation of the repository, how do you know? Let's say someone else's repository, so you have just got a repository. Whether you want to do a commit, you want to do a add, you do not have any, you don't even know which files you have. You do an ls, you see some files. What do I do? If you need to check the current status, just write down git status. That's the command. It'll tell you, see, no commits yet. Untracked files. Untracked files means the files that has not been added, right? Use git add and the file name, file under text. So to include in what will be committed, right? Exactly what I told. What all things will be committed, right? Just add the file under text over there. If I write git add file under text, now if I try to see the git status, see, it says still says there is no commit, but you have already got some changes to be committed, because now this file you have, because it was like just a blank focus, nobody is coming into the focus. What will you take the photo of? A person has to come first, at least one person has to be there. More person can be, at least one person has to be there for you to click the photo. Exactly like that, for you to commit, at least one file has to be added. We just added it. Okay, new file, file under text. So it is telling new file because it is a newly being added. If later I change the file and again go for a commit, I can do it very easily. It will not say it is a new file, but this is the first time we are adding. So whatever is written in the file, everything will be addition. You remember 118 additions, new file, right? That's what it is. Now let us go for a git commit. If you remember, I told you that you have to always associate with a message if you're committing -m, and you have to write a message. Let's say initial commit, adding file one message. -m you have to put and then you have to write the message. Okay. If you do not do that, what will happen? If you just write git commit, say it is asking you, please enter the commit message for your changes, right? So you have to add it over here. So sorry, initial comment. Better you write it over there only, just -m, right? File one added. You do a WQ, just like a VI editor, and then you can see, well, read this thing. Don't read this part. This is not required as of now. This will come into picture when you do a GitHub connection. Okay. See, initial commit, one file added. This is my message, right? Initial commit, file one added. This is the message I wrote. And what it did, it is telling the committer is EC2 default user, which is EC2 user at this particular, because this is the user over here. There the committer was Sona Sonaram, because the user was Sona Sonaram. Here who is the user? EC2 user. EC2 user is the person who did the git init, who did the git commit. If I created a new user with the name, let's say Vishal, and Vishal was doing the commit, the username will come as Vishal, right? Whoever has done it. Achha. And if you see over here, 3 insertions, correct, right? We had 3 lines. This is first line, third line. 3 lines we had, right? Just check it out.
Yeah.
We had 3 lines. So it is telling 3 insertions, right? 1 file changed, 3 insertions. Got the point? Let us try to modify this file, okay? I'll modify this file. So I'll kind of, okay, using cat only I can do it. File on the text. So new line added. Oh, sorry. So now if I do a cat of file, you'll now see there are 4 lines, right? Oh, I was supposed to put double arrows. I gave one. Anyway, fine. So this is even better. This is deletion plus addition, right? 3 deletion, 1 addition. That is what you are expecting to see over here. I don't know, because of this control C, will it take 2 additions, or it should not take, or ideally. Let us see. So what we shall do, again check the git status. What it is telling, it is not telling new file, right? Last time it told new file, if you see, right? It told untracked files last time. This time it is not telling untracked, because it already knows about this particular file. It is just telling that this file is not staged. So it is like one person comes, you took a photo, now your camera identifies the person, but next time the person is not coming under the focus. So it is waiting, okay, fine, come under the focus, I have to take a photo of yours, right? So it is telling that this file is there, but you have not, no, stage the file. You have to stage it. Otherwise, if I simply done a git commit, let's say I'm writing a message, hi, I'm simply writing something. What it says, that no changes added to commit. Even though you know there is a change, but I am not putting in the staging area. As long as it does not come to the staging area, it will never be committed. Once again repeating, in GitHub, when we are pressing commit, it was automatically pulling in the staging area and doing it, because it is not in the staging area. Whenever you change a file, you have to take that file, you have to bring that file under focus. You need to tell Git, okay, see this file I have changed something in this file. I want this file to be committed when I run the commit, right? We have not done that over here. So in GitHub, when you are pressing commit, it was automatically doing that for you. So you never had that step over here, but you have this step over here. Okay. So you have to say GitHub that okay, Git that okay, see this file have changed. Please take this file for committing. It did not commit anything. I mean, if I had another file, it would have committed that one. If I had staged something, it did not commit anything because no change is staged. Nothing is staged. The focus is blank. You are asking the camera to take a photo. Why will the camera take a photo? There is nobody, right? It does not want to waste something. So I have to add it once again. So go for git add. What is the name? File1.txt, and then go for git commit. Write a message. Modify it. File1. Right. And this time see 3 deletion, 1 insertion, right? 1 add, 3 delete. Correct? That's what we did. 3 lines were there which we deleted and we added 1 single line. Everybody getting the point? Yes?
Yeah.
Others? Karthik? Sunil? Junaid?
Yes, Vishal.
Yes.
Okay. So, okay. Let us try to add a new file. I'm exactly doing what I did in GitHub. I created a new file, I changed it. Now I'm going to add a new file. Okay. So, but one thing which I'll do over here, okay, fine. No, before that, let me show you the commit history. How do you check commit history over here? You check it over here by writing git log. Git log shows you the commit history. It was the first commit, whatever E2B, A180, something. This is the second commit, right? See the commit message is also coming. Initial commit file one added, modified file one, right? Like this. Clear? I'll take the comments, whatever I ran so far, I'll give you the comments. I'll write it in the notepad as of now. I'll upload this notepad. These are the comments so far we ran, right? Let's again do a little brief discussion on what we did. First we ran a AM update. This is for updating, right? This is nothing related to Git. Git installation started over here, right? This was Git installation. This Docker repository created for and then I did a git init over there, right? So this git init when I did, that was actually initializing git within my folder, right? It is creating the file.
We can edit also, right? We are editing and creating both. Okay. Chat is only for editing and appending. Creating and appending.
Creating also you can do in CAD.
Yes.
Everything we can do in CAD, but you cannot edit the previous lines.
Yes.
That is something you cannot do. Clear, huh? These are the things we did. Okay, I'll keep it over here. Any doubt? No doubt.
So how is this related to? No doubt. And one more thing, whatever we have added the file, if we go and check it in GitHub, these
No.
are
We have not yet connected with GitHub. It is just locally we've done Git. If we
okay.
connect it with the repository on GitHub, we can create a repository over there and we can connect it with GitHub. Then when we push this to GitHub, it will go and sit onto the GitHub. Okay. So as of now, the GitHub part we already seen it. So Monday, what we shall do? Monday we shall be creating. I mean, I will anyway terminate this EC2. So I'll quickly install Git, creating a new EC2. I'll show you first connectivity with GitHub. Then I shall create a file and push it. So and we have to create an empty repository over there. There is no such requirement that the name should be same of the repositories. There you can have like my XYZ repository, and here you can have hello repo. It is fine. They will work. You just need to give the reference. Okay, this repository is to be connected with that repository. So upstream should be that one, and that guy's downstream should be this one. So this upstream downstream connectivity has to be done. If we are only planning to push code from here, we do not need to set any downstream to that GitHub. This upstream is only fine from Git. If we plan to pull from GitHub, then there has to be a downstream to this Git, right? We'll do everything, right? We'll do everything. Fine, Sunil, clear?
Yes.
Yes, so this is still not at all related to GitHub. I mean, this local repo. This is just in our local. I just wanted to show you in today's session that on GitHub we can do everything. It is a decentralized architecture. I told you, right? So here we are doing everything. Now, if I switch on the internet, the Zoom meeting will stop. But typically, my Git work is not requiring an internet, right? I am using EC2. That is a different thing. I need internet for that. But typically, for doing Git, I do not need internet. I am not hitting the outbound barrier of my server at all. I am doing
Yes.
server.
Yes.
That is a decentralized. So what you can do in Git are the same thing you can do in Git also, and you can connect also. So you can do the task over here and push it over there. There you don't know transactional. Getting the point? Clear? I'll
Yeah.
stop.
Yeah.
Any more doubts from anybody? Yes, no,
No doubt.
no doubts. Monday, this apart from Mallikarjun batch, the other people that is Mithun, Junaid, Sunil join at 8:45 itself, but probably at least till 9 we shall start. But just join at
Okay.
8:45.
Okay.
Okay.
So this recording you will in the share folder.
The folder is already shared with you actually.
Okay. Okay.
The folder I showed you, it is already shared. So I mean, yeah, it is already shared. I'll open it up once again. Okay, what did I do? I'll stop the recording. Hang on a second.